Here are your examples for 7-5. 7-5 is similar triangles and indirect measurement. So we're going to use the concept of similarity in order to find a measurement indirectly. Let's look at our key concept here first. We're talking about angle-angle or AA similarity. In words, we would say if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So the key thing is here we do not have to prove all three angles congruent. If we just come up with two angles that are congruent, we know that the two triangles are congruent. So in symbols we could put it like this. Angle A and F are congruent and angle B and G are congruent, then these two triangles are congruent. And of course we're looking at the triangles down here because we have B and G congruent and F and A congruent. Another way to look at this is down below here where it says in the figure below we have X and P are congruent and Q and Y are congruent. If you were to extend the sides of each figure to form a triangle, you can see that the two triangles are similar. So triangle similarity can be proven by showing two pairs, just two of the pairs corresponding angles are congruent. We have similar triangles. All right, let's take a look at problem number 1. We're asked to determine whether the triangles are similar, and if so, write a similarity statement. So we have two angles that are congruent, 62 and 62, but the others are 48 and 70. So we can think about what this angle has to be, and we could take 180 degrees, subtract the 62 we have right here's that, and then subtract the 48 we have right here, and we can prove that this angle is 70. Once we have that, we have another angle right here, 70 and 70, and therefore we can prove that these two triangles are similar because they have at least two angles in common, or are congruent measurements. So we can say that triangle ABC is similar, remember the similar symbol, similar to triangle EFG. Please press pause and do letter A. So now we're going to do some indirect measurement. One type of indirect measurement is called shadow reckoning. Two objects and their shadows form two sides of right triangles. In shadow problems, you can assume that the angles formed by the sun's rays with two objects at the same location are congruent. Since two pairs of corresponding angles are congruent, the two right triangles are similar. You can also use similar triangles that do not involve shadows to find missing measures. So let's take a look at what that looks like. Here in problem number 2 we have that exact situation. We have a fire hydrant that's 2.5 feet high and it casts a 5-foot shadow at this particular time. So that's represented right here. We also have a lamp post, a street light, that casts a 26-foot shadow right here, and we're being asked how tall is the street light, and we're going to use H to represent that. So we can set up a proportion. We can look at the 5 is the shadow of the hydrant and 26 is the shadow of the street lamp. So those two are right here. So 5, the way I read this is 5 is to 26 as 2.5, that's the height of the hydrant, 2.5 is to the height of the street light. Now there's lots of different ways that you can set up these proportions. So this is just one example of that, and make sure you understand that many kids will do this a little bit differently, but the key is, again, don't make one of those U-turns that we talked about earlier in the year. Make sure if you start with shadow to shadow, then you move to height, and if you start with the shorter shadow, like in this case 5, to the longer shadow 26, then you have to go with the shorter height 2.5 to H, etc. So in this particular case we would multiply 5 times H so that we get 5H, and then 26 times 2.5 would be 65. Divide both sides by 5 and we could show that the street light is 13 feet tall. Let's take a look at another way to do one of these problems that doesn't involve shadows. In problem number 3, in the figure at the right, triangle DBA, so this triangle here, DBA, the smaller triangle, is similar to triangle ECA. Ramon wants to know the distance across the lake. So he sets up these two triangles and makes all of these measurements, except of course this measurement right here. So we have this following situation. We have AB, this line here, over AC, which is the full distance here, is congruent to BD, which is right here, BD, over CE. So we can put numbers on that. For AB, we can use 320. Now notice for AC, we added on the 162. Don't get confused here. Just put the 162. We need the full distance from A all the way to C, which would be 320 plus the 162, which of course is 482. And then lastly, we have the distance from B to D is of course 40. So we have 40, and we're looking for D right here, our distance, D. So we have 320D equals 482 times 40, and that's 19,280. We divide 320 by both sides, and we end up with a distance of 60.25. So the distance across the lake is 60.25 meters. The key again here is to find two sides that are, find the sides of the triangle where you have measurements and compare those two sides, and then the other side here, in this case it was the 40, that's congruent, or that's similar and to a corresponding side that you're looking for. And once you've got your ratio, you can do the cross multiplying, or you could have just used the ratio or the scale factor in order to find that measurement. Most kids will do it this way, and this is the way I'm always going to do it on the problems, is by cross multiplying. Please press pause and do letter B.